Topic 2 is going to be about problem solving with circles, and there are several definitions and facts that I need to make sure you know before we start talking about area and circumference of circles. So first, a circle is a set of points in the plane equally distant from a given point, its center. So we all know what a circle looks like. We can all envision the center of the circle. From the center of the circle, if I draw it to draw from the center to the edge, anywhere on the edge, it doesn't matter. I could do this 10,000 times inside the same circle. That distance from the center to the edge is going to always be the same. Okay, and that's what makes a circle a circle. So again, it's a set of points equally distanced from the center of the circle. All right, so again, we can all envision a circle. Now we need to talk radius and diameter. So when you're dealing with a circle, the radius of the circle, lowercase r is what we're going to use for radius. The radius of the circle is the distance from the center to any point. Okay, so envision a circle. I will try to draw one that's at least decent. Done worse. All right. Envision the center and then draw a line anywhere to the edge of the circle. I could draw this in any direction, it doesn't matter, but that distance from the center to the edge of the circle is the radius. Now we also have to envision the next definition, which is the diameter. So the diameter, lowercase d, of a circle is the distance across the circle, so all the way across the circle, but the condition is you have to go through the center. So again, envision that center and then draw a line through it, and that represents the diameter. So if you think about the diameter right here, if I go to the right, I've got one radius. If I go to the left, I've got another radius. So basically the diameter is 2 times the radius. So you do need to understand that the diameter is 2 times the radius. With that said, you can see the radius is halfway across the circle. So the radius is half the diameter, and that's a really important piece of information. So instead of thinking half the diameter, you could think the diameter divided by 2, same difference, okay? So make sure you understand visually what the radius and the diameter are, technically what the radius and the diameter are, and make sure you also understand the connection between the radius and the diameter. Next, we get the circumference. The circumference is similar to perimeter, but because a circle is not really a polygon, we have to call it something else. So the circumference of a circle is the distance around the circle. So any circle, all right, I'm going to pick a point on that circle, and I'm going to go all the way around the circle. That is your circumference. We use an uppercase C to indicate circumference, okay? Now, another really important thing that's going to show up in our circumference and our area formulas for a circle is pi. So pi, not pie that you eat, pi, the number. Pi is an irrational number. That means it's a decimal that never terminates, it never repeats, okay? So oftentimes when we talk about pi or we refer to pi, we just use the actual symbol pi. We're like, hey, it's pi. It's this number that never ends, it never terminates, it never repeats, okay? But because that's not super useful to us always, we oftentimes have to estimate pi using 3.14 or 22/7. So keep those numbers in mind. They're going to show up anytime you work with circles. Now, pi itself is the ratio of the distance around the circle, which we know to be just the circumference, to its diameter. So basically, pi is going to be equal to the circumference divided by the diameter. And that's like a really, really cool thing. You take any circle, it doesn't matter the size, you measure the circumference, you measure the diameter, and you divide the two, and you're always going to get approximately 3.14 or approximately 22/7. So again, circumference is, pi is always circumference divided by diameter. Okay. Now, as far as the formulas go, we have 2 formulas. We have circumference and area, and then circumference kind of has 2 versions of the same formula. So remember, circumference is kind of like, think perimeter, even though it's not perimeter with a circle. It's the distance around your circle, and it can be calculated by 2 times pi times the radius. But remember, 2 times the radius is really just the diameter. Remember, diameter is 2 times the radius. Okay, so the circumference formula is 2 times pi times the radius, or you could just do the diameter times pi. They're the same thing. Now, when it comes to the area of a circle, the area formula is pi times r squared. So pi times the radius squared. All right, let's look at 2 examples. So first, we want to solve each problem, include units with your final answer. Okay, so in this problem, part A, we have the diameter of a circular pool is 40 feet. So we know we're dealing with a pool. We know the diameter is 40 feet. So that tells me that the radius must be just 20 feet. Okay. We want to find the area and the circumference of the pool. We want to express the area in terms of pi. That means instead of using an estimate for pi, we just leave the pi symbol in the formula. And then there is a little typo here that should say then round the answers to the nearest square foot. Okay. So let's see here. For the area, we'll do area first. We want pi r squared. We know the radius is 20 feet. The diameter, the distance all the way across the circle or all the way across the pool is 40 feet. The radius is half of that. We need the radius, so we're going to get pi times 20 squared. And we want to simplify this first, just leaving pi in the answer. That's going to be the exact area, okay? We can't ever get an exact value for area with a circle unless we just leave the pi symbol in there because it's a decimal that never terminates, it never repeats, okay? So to get the answer in terms of pi, we're just going to figure out what 20 squared is. Well, 20 squared is 400. So we're just going to leave it 400 pi feet squared. So that is the exact area of the circle. That is the area in terms of pi. But that's not typically super useful to us. We generally need to estimate some value for pi. So 3.14 or 22/7. So let's go ahead and get an estimate. So instead of using the pi symbol, we're going to replace pi with 3.14. All right, so let's go over to the calculator. So we have 20 squared, just to make sure you're clear, 20 squared is 20 times 20, which is 400. And then we want to take 400 and multiply it by 3.14. Okay, so 3.14 gives us 1,256 feet. Now, when you're told to estimate or get some kind of rounded answer for circumference or area, anything involving pi, you really do have to use the estimate they tell you, because if I were to use 22/7, for example, I'm going to get basically the same thing, but not exact. So in this case, I get 1,257.1. That's really close to 1,256, but it's not exact because 3.14 and 22/7 are different estimates for pi. You could also use the pi button on your calculator, which is going to be similar to 3.14, but it has way more decimal places. So we could take 400 and we can multiply it by pi on our calculator, and we would get, again, something different, 1,256.63, blah, blah, blah. So when you have a problem involving pi, use the estimate that the problem gives you. Otherwise, your answer would be slightly wrong, especially if you're doing like online homework where answers are programmed in. So just make sure you're consistent. So I said we're going to use 3.14. Make sure you use 3.14. So we would get 1,256 feet. So the area is approximately 1,256 square feet. Okay? Now let's do the same thing, but this time we're going to do the circumference, which, remember, that's the distance around the circle. So circumference is just d times pi, or 2 times the radius, which is the diameter, times pi. So we're just going to use d pi since we have the diameter given to us. So that's going to be 40 times pi feet. Since circumference is similar to perimeter, we just use linear feet as our unit. We don't have to square the unit or anything. So that's the exact circumference of the circle. Okay, we've written this in terms of pi. That means pi is still in the answer. But again, oftentimes we need to do some kind of estimate. So let's use 3.14 again. So I get 40 times 3.14 feet. Some of you will be able to kind of figure out what this answer is, because 40 is basically 400 divided by 10. So we could take our previous answer and divide it by 10, but let's just go to the calculator. So we're going to get 40 times 3.14, and that gives us 125.6 feet. So let's go back to the worksheet. So we get that the circumference is 125.6 feet. But if we're going to be true to this worksheet, it says round the answers to the nearest foot. So we would say the circumference is approximately 126 feet. Okay. So read directions carefully if they say to write your answer in terms of pi, or if they say give an exact value for the circumference in the area, leave pi in your answer. If they tell you to estimate, make sure you use the proper estimate for pi. So they should give you, like if they say estimate, they'll say estimate using 3.14 for pi, or estimate using 22/7 for pi. Okay, just make sure you use the correct one, otherwise your answer might be different. All right, part B, it says determine which is the better buy. Anytime you're doing a better buy, you're taking a price and you're dividing it by the units and then you're comparing those. Whichever one is the smallest is going to be the better buy. This is something that a lot of shoppers do. So let's say you go to the store and you want to buy pickles. There's a 12-ounce jar of pickles. There's a 16-ounce jar of pickles. They have different prices. You're like, well, goodness gracious, which one's going to be cheaper for me? So what you do is you take the price, you divide it by the units, and then you compare the unit price. We're going to do something similar to that just with pizza. So we have two pizzas. We have a 14-inch pizza, and then we have an 18-inch pizza. And what you need to know is pizza is measured by its diameter. So if we're talking about a 14-inch pizza, it's got a diameter of 14 inches. So let's go ahead and figure out the area. And in order to do the area, we need the radius. Okay, so if we have a 14-inch pizza, the radius is 7 inches. If we have an 18-inch pizza, the radius is 9 inches. Okay, so keep that in mind. Now, we're going to have to calculate the area first, okay? And then we're going to take the cost of the pizza and divide it by the area. And that'll tell us the basically like the unit price for each pizza, and then we'll compare. All right, so let's do the area of this pizza. I did not specify, but let's go ahead and use 3.14 for pi. So we're going to get pi, which is 3.14 times the radius squared. Now, you do have to remember the order of operations. And this wasn't something I explicitly mentioned in the previous example, but I'm going to mention it here. We have to follow the order of operations always, okay? In this particular problem, we have multiplication and we have exponents. Notice in PEMDAS, remember PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. The exponents come first, the multiplication comes second. So make sure when you're doing your area calculations with a circle, you do the exponent first, then you do the multiplication. So that tells me that we're going to get 3.14 times 7 squared, which is 49. Let's jump over to the calculator really quick. And we get 3.14 times 7 squared, which is just 49. And we get 153.86. So this is 153.86 square inches. Okay, we'll leave that there for now. We'll come back and do the price in just a minute. Let's look at the area of the 18-inch pizza. So an 18-inch pizza, that means the pizza has a diameter of 18 inches. The radius is 9. So we have the area. Again, we're going to use 3.14. We're going to multiply that by the radius squared. So pi times the radius squared is going to be 3.14 times 9 squared. Because of the order of operations, we have to take care of the exponent first. So 9 squared is 9 times 9, which is 81. So I get 3.14 times 81. We're going to mosey on over to the calculator. And we get 3.14 times 81. We get 254.34. Whoops, I shared the wrong screen. I was patiently waiting. There we go. So we get 254.34 inches squared. Now we have to do the part where we talk money. So we want to get the unit price, which is basically price divided by units, okay? So now for the cost, we're going to take the price of the 14-inch pizza, which was $14. We're going to divide it by the area of the pizza, which is 153.86 square inches. All right. I have this written down on another sheet. Just make sure I don't forget when I go to the calculator. So what we're going to do is we're going to take 14 and we're going to divide it by 153.86. And we get, if we were to, oh, I didn't do 14, I did 11. So 14, excuse me, divided by 153.86. And we get 0.09099. So if we were to round this, we would go, we've got the 0.09. That first 9, we want to look to the right of it. We have a 0. That tells us to round down. This is going to round to approximately 9 cents per square inch. Okay, so let's go back to the worksheet. So we're going to say this one is 9 cents. So we would write it 0.09 per square inch. Now let's do the same thing, but this time for the 18-inch pizza. So the 18-inch pizza costs $20. we're going to take the $20 and we're going to divide it by the area of the pizza, which is 254.34 inches squared. Let's go to the calculator. So we're going to go to the calculator, we'll divide, and then we'll round. So we're going to take the cost, which was $20. We're going to divide it by the area, which was 254 point something, 34. And we get 0.0786, blah, 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 blah. So that's 7. That's the 2 decimal places, because money, we always think 2 decimal places. So we're going to look at this 7 right here. 1 digit to the right of that is an 8. That tells me to round up. That means I add 1 to the 7 and then just chop everything after that off. So we're going to say the 18-inch pizza is approximately 8 cents per square inch. Okay, so this is approximately 8 cents, so 0.08 per square inch. So which is the better buy? Well, it just so happens the 18-inch pizza, though more expensive on the surface, is actually cheaper per square inch of pizza. So the 18-inch pizza is cheaper, or we would say the better buy. So when it comes to circles, make sure you remember radius and diameter and the difference between those. Make sure you understand circumference, area, understand what pi is and how to estimate using pi. So just get a little bit of practice playing around with area and circumference.